Greetings, it's David with Nemesis Giant here. Today we're going to look at an alien megastructure star is freaking out again. Filed to not saying it isn't aliens. Now this would happen to be talking about Tabby Star, if you don't remember it, from 2015. It's a girl named Tabitha Boyan discovered this star, and it was flickering, and astronomer Jason Wright had proposed that it was an alien megastructure. Now I'm not going to read this article. I want to get to, there's an interview with him from the Berkeley SETI group, and it's an hour-long interview. I'll scroll through it real quick here, just in case anybody wants to read it. You can go back, pause it. I'll leave a link to this article with the video. On this page, there's actually some other neat articles. Here's 3 more about the alien megastructure. And under here there's another one about dark matter, and then an article about the ransomware attack. So you may want to check them out too. But let's go back up here and see what Dr. Wright has to say about Tabby Star. I'll probably break this down into 3 or 4 different videos, but maybe we'll check out the first 15 minutes of it here today. Get it to where you can see the whole thing and not just my face. I'm going to break out of here probably. Okay.
All right, we're live. And all right, there was Professor Jason Wright from Penn State University, who is going to tell us a little bit about some exciting stuff that's been happening recently with the most mysterious star in the universe, Tabby Star. Maybe you can just lead us off, Jason, telling us what's exciting that's happening right now.
Sure. Well, it's kind of a weird coincidence that I'm here in the Breakthrough Listen Lab at UC Berkeley when all of this started happening. So, Tabby Star, as you may know, went through a lot of very strange dimming events. It got up to 22% dimmer during the Kepler mission, and since then we've been eagerly awaiting another dip. And the reason that we've been waiting for that is that whatever's causing the star to get dimmer will leave a spectral fingerprint behind. So if it's a lot of dust between us and the star that's passing by, it should block more blue light than red light. If there's gas in that dust, that gas should absorb very specific wavelengths, and we should be able to see that. And so we've been eager to see one of these changes, one of these dips of the star, so that we can take some spectrum. So all week there have been some indications that something might be up, and yesterday we were on yellow alert. There was evidence from Fairborn Observatory in Arizona. Matt Petersball let us know that they were seeing what looked like some dimming events, but nothing was significant enough for us to really hit the big red button and get everybody on red alert to start taking spectrum when this happens. One of the difficulties here is that most telescopes are scheduled weeks, months in advance. And so we can't just jump on a telescope and take a spectrum typically. And so we need to have a network of people around the world that are ready to jump on. And fortunately, Tabby Star is not too faint. And so there are a lot of observers on telescopes around the world tonight, actually, that have graciously agreed to take some time out of their science to grab a spectrum for us. Anyway, so the punchline is that yesterday we were sort of on yellow alert waiting for data to come in to tell us if the dip was really happening. And sure enough, at about 4 a.m. This morning, I got a phone call from Tabby that Fairborn Observatory in Arizona had confirmed that the star was 3% dimmer than it normally is. And that is enough that we are absolutely confident that this is no statistical fluke. We've now got it confirmed at multiple observatories, I think, that the star is indeed So I guess I can show these data. Steve, do you want to put one of those up?
Sure. Which one do you want?
Okay, I don't know if this is coming through. Is there a way to zoom that in or project this in some way?
I can see if I can share this on.
Yeah.
Here, yeah.
All right. Well, Steve, we'll see if we can get the data shown so you can see exactly what this looks like. Because I don't think it's coming through on the webcam right now. The punchline is that it's been more or less stable in brightness for as long as we've been measuring it. There's some indications that maybe it's been slowly getting dimmer. That's the other strange thing that this star has been doing. It's been very slowly getting dimmer over many years, and we've been accumulating evidence that may be continuing to today. But just in the last 2 days, it got dramatically suddenly by about now, as of this morning at 4 a.m. Pacific, about 3% dimmer. And so we are officially on alert, and we are asking astronomers on telescopes, including amateurs with the American Association of Variable Star Observers, and all the way up to the spectroscopists on the PX.
Now, why don't we do this with Nemesis?
To please take spectra of the star, multiband photometry of the star. We're going to do everything we can to understand how the dimming is different at different wavelengths, because as any astronomer will tell you, the key to understand what something is made of is to get a spectrum of it. And now we are able to get a transmission spectrum of whatever is blocking light. I think that's everything we've got right now. We're organizing lots of different telescopes. We have observers on the both Keck telescopes. We have an observer who's offered us some time on the MMT in Arizona. We have a team member that's trying to get infrared observations at the Large Monocular Telescope in Arizona. We're going to try to use the Minerva Telescope Array in Arizona. I'm going to trigger, as soon as I get around to it, some more spectra at the Hobby Everly Telescope tonight. I know I'm missing a whole bunch of things that we're all trying to get done. But it's been kind of a crazy last 18 hours, and it'll be a really exciting weekend. So Steve, is this one up? Not quite yet, okay. Let's see, what else can I say before we get to questions? So Steve is frantically working here to try and show you the data so that you can see what the what we're talking about when we say that it's getting dimmer. Oh, so where am I exactly? I see a question on one of our channels here.
Yeah, this is up, actually.
This is up. Okay, great. So here is the this is the light curve from this is Fairborn Observatory. Matt Uterswasser has this plot recently, and it shows all the red points for most of this are just essentially the star being more or less the same brightness. The green points around 578060 to 57880 were the first hint something wonky might be going on. There was that cluster that was a little lower than usual, and so we started getting very interested. And then the blue points are what Matt has labeled event 2, and you can see that they are significantly lower. One of those points has very low error bars, so it's highly statistically significant. And so the fact that all of those went down, those are the observations that had us push the big red button, so to speak. And then we get the LCOGT data as well, which is the next, the next one over.
Oh, that's on here, so I gotta, sorry, load that up on.
Okay, and there's one more that I'll show in just a bit.
Right, I'll just stop this for a second and go back on the video again now. This is some horrible URL that I'm going to have to type in here, so keep talking for a second.
No problem. Do you want me to paste it into the, I can just paste it.
Maybe easier if I just do this. Okay. I don't know how I get that.
Let me see, maybe I can find some questions here.
And here comes Dr. Andrew Simmons. Do you want to sit around this side, Andrew, and you can join the chat? You can be on the screen. Actually, I guess we can see.
And then overhearing the very exciting chat.
Okay, we're live now, so do you want to introduce yourself, Andrew?
Yes, I am
Andrew
Simeon here in the Berkeley SETI Research Center, Breakthrough Listen Lab, and it's Super Bowl Sunday.
That's right, it's the main event.
Everybody's been quiet since we're broadcasting here, but it's certainly a palpable tension.
That's right. So we have Green Bank. We're hoping that we'll be able to make some Green Bank up.
Yes. So
permission. I was explaining that telescopes don't schedule on this kind of short notice, and so a lot of this is begging and borrowing and asking, and a lot of people graciously offering their time to us.
Yeah, absolutely. I mean, I think that's kind of a really fun thing about moments like this is that you get these giant email threads with astronomers from all over the world, especially in a situation like this.
And people you've never met.
Yeah.
And they're just like really wonderful about this.
So let's see, as far as Breakthrough Listen goes, we're confirmed on the automated planet finder. This is a 2.4 meter optical telescope with a very precise spectrograph. It's here in California at Lick Observatory. We'll have a 1 hour exposure on KIC 846-2852 this evening. That's confirmed. And we're working with our colleagues at Green Bank to get on the facility here in probably the next 12 hours or so.
Great.
So as Jason said, this involves some kind of informal swaps with other observers at the telescope, but we're hopeful we'll be able to get some time there as well. So it's very
so these would both. So the Green Bank observations, to be clear, would be with the Breakthrough Listen SETI radio backend.
That's right. Yeah, the Green Bank telescope is a 100-meter class radio telescope. It's one of the largest fully steerable radio telescopes in the world, if not the largest. It has a really fantastic surface accuracy. It allows it to observe at very, very high frequencies, up to about 100 gigahertz, 115 gigahertz or so. And I think essentially our plan will be, although this is very much in sort of discussion here this afternoon, is to observe at as many wavelengths as we can. Cool. So with as many receivers as we can observe. And of course, this is really an extension of the program that UPI, which was awarded time from the Time Allocation Committee for the telescopes. We already have 24 hours of data with Jason's program. But it's very exciting to actually get data when one of these dimming events is happening.
And since we're doing this, and people have been asking, we collected about 610 terabytes or 600 terabytes of data. And it turned out that the safest way to move that much data to Penn State, where we will do the analysis, was just over the internet. And we have the third run is supposed to complete its transfer to Penn State this weekend. And then the fourth run and final run will happen over the next couple of weeks. And one of the reasons I'm here actually is to get the software running at Penn State so that we can do the really thorough, careful analysis that we want to do with those data. We have a whole bunch of questions here, now I see. And there's, okay, go ahead. Oh yeah, why don't we see the LCOGT data while here? Great. So these are the data from the Luz Cumbres Global Telescope Network. These are data that we are able to take thanks to our Kickstarter backers who participated in the Where's the Flux Kickstarter. And we now have a year of time that Tabby manages on this telescope network. And so the tick marks on the bottom are in units of days. And you can see, just like with the Fairborn Observatory data, things are very constant until just the last couple of days. We saw this big dip that had us on yellow alert. And then last night, or this morning, things were way down a full 2.5% from baseline, or 2%. This is a slightly different filter, so that's not necessarily inconsistent with the Fairborn data. And that's what's got us all so very excited. So yeah, it has been all over Twitter. My phone has just been going crazy.
Charles Choi had a question, the American, how soon might you be able to know something?
It's a good question. I guess it depends on what we see. You take data at the telescope, you have to reduce it. And so that means you have to take what the telescope gives you and turn it into some sort of spectrum that you can analyze and look at. So the observers on tonight will have automated pipelines. They can just turn the crank, and by tomorrow morning, you'll have beautiful spectra that we can then inspect. Others will be changing their their instruments into modes they don't normally use, and that those data will take some more time to reduce because they'll have to tweak their pipeline to properly handle it. And then I guess it depends on what we see. If we see much stronger line. Oh, the other issue is whether we have data from that spectrograph before. If we take data with the same instrument in the same way, then it's very straightforward to look for tiny changes in the spectrum. But if the data we're taking with very different instruments, then you have to ask what differences are due to the fact that they're different instruments and what's due to the star itself. And that's a more involved analysis procedure. And so that'll take a lot longer. I don't know what we'll see. It could be we'll look at the data and throw up our hands and say we have no idea, this will take months to understand, or it could be something painfully obvious and we'll all slap our foreheads and say, oh, that's what it is. I don't think we're going to solve the puzzle this weekend, but it is possible that this weekend will be the weekend where we took the data that solved the puzzle. But we've, a lot of people here contributing a lot of data, and it's going to take a lot of time to sort through it all and figure out what we have. But it's all very exciting.
I think from the SETI standpoint, one thing to keep in mind is that our ability to discern some signal as being technological depends quite a lot on how strong the signal is. So if there's something as obvious as the dimming in the radio, we would know that immediately after taking these data. So we actually have a real-time analysis pipeline for breakthrough listen that we've just gotten working in the last several months, and we'll be deploying that pipeline on the observations with GVT this evening if we can get on the telescope. And so we would know very, very quickly if there was something associated with the dimming event also in the radio. So I think an exciting couple of days ahead of us.
That's right. People wanted to know if the dimming is a surprise. Yes, there was no real.
Okay, so that's the first 15 minutes or so, and